Okay, so this truly is the last video for this section, right? Lots of moving parts in 2.6. But now that we know that there's several different ways to represent a solution set, what I want to do is just kind of bounce back and forth between each one. That way we can kind of get used to it and get familiar with the idea. So for the first one, I'm starting off with an inequality. So I'm saying that x is to the right of or greater than or equal to 3. So if I was to graph this on a number line, right, we're going to, here's 0, here's 1, 2, 3, 4, 5, right? We're allowed to be equal to 3. 3 is serving as a boundary. So I'm going to use a colored dot there, or a closed circle, and then we are greater than 3, or to the right of 3. So what numbers are we talking about? Well, we're talking about 4 and 5 and 6. So we're actually, right, basically coloring in that. So there would be a visualization of that inequality. All right, so we're talking about number starts to the right of at least equal to 3. So we're talking about 3 and everything to the right of it. So there's your picture. Interval notation, again, I have to talk about left bound and right bound. So what's bounding this interval to the left? Well, the number 3. What's bounding this interval to the right? What's not bounded, right? It goes on forever. So that is infinity. Open or closed parentheses or brackets. Well, we're allowed to be equal to 3. So I use a closed bracket. We can never be equal to infinity, right? This goes on forever and ever. So we use a parentheses. So there would basically be 3 ways to describe the same set, right? An inequality way, a picture way, and then the interval notation way. So 3 ways to say the same thing. What happens if we start off with a graph, right? Well, if we start off with a graph, perhaps an interval notation is the easier one to start with first, right? What's bounding this set to the left? Well, it looks like, again, we're about at the halfway point on the negative side. So it looks like my left bound is negative 1/2, and then we're going on forever, so the right bound is positive infinity. Open or closed, right? Well, we're allowed, looks like a closed dot at negative 1/2, so we're going to be closed, and then we're never allowed to be equal to infinity, so that would be open. So there would be the interval notation. What about the inequality? Well, for starters, negative 1/2 is serving as my bound. And then it looks like we're talking about values that are to its right. So you could say this a couple of different ways. You can say that x is greater than or equal to negative 1/2, right? So x is to the right or equal to negative 1/2. Or you could say that negative 1/2 is less than or equal to x. What we're basically saying here is that negative 1/2 is to the left, or at least equal to my x values. So there are actually 2 ways to describe the same set. As a matter of fact, going back up to here, we could have said that 3 is less than or equal to x. And so all those alligators and Pac-Mans and those crazy things that we learned in elementary school, they don't work. All right, it's probably why we're constantly confused. What I like to use is a language to the left and to the right of, and then this starts to make sense, right? We're talking about numbers to the right of 3. Well, there they are. We're talking about 3 being to the left of x. Well, there they are. 2 different ways to say the same thing. I'm saying x is to the right of negative 1/2. Well, there they are. I'm saying that negative 1/2 is to the left of x. Well, there they are. All right, so 2 ways to say the same thing. That can get a little challenging. Last but not least, we start off with a interval. So perhaps we'll start with a picture first, right? So it looks like my left bound's negative infinity, so we're going to go on forever in this direction. And we're going to have negative 2 and negative 1 and 0, 1 and 2. And then it looks like we're bounded by negative 1, but not including it. So I'm going to have an open circle at negative 1. And we're talking about everything to this side. And so there would be a picture of that interval notation. Left bound, right bound, open, open, everything in between. All right, and then what about the inequality? Well, as you've seen, there's 2 different ways to say it. Here's one. We can talk about all the values that are to the left of negative 1. So perhaps we say it that way. X is less than negative 1, or in my language, X is to the left. Or you could say right, that negative 1 is to the right of all my x values, or negative 1 is greater than all these x's. So again, two ways to say the same thing in inequality-wise. And there's your conversion. Please make sure you get proficient at all three. Again, as you solve inequalities, you'll probably get this, and then you'll be asked to graph, and then this is, again, major. Interval notation is very big as you move through your math career, so let's get very familiar with it. That should wrap up 2.6, and now that we've started to graph, we're ready to actually start doing more graphing situations, and that's what we're going to encounter in Chapter 3.